Hello guys, welcome to Deep Codes, and in today's video we will discuss today's problem of the day of in the Geeks for Geeks portal, and that says connect nodes at the same level. So here you are given a binary tree, and each binary tree, each nodes of the binary tree has some pointer that says next right, and you need to add the value to this pointer next right. Okay, so as you can see here, the next right of to the 10 is null, so we don't do anything, we keep it as null. For this 3 its next right is 5, for 5 it's null, for 4 it's 1, for 1 it's 2, and for 2 it's null. So yeah, I hope you guys understood the question that what we are trying to do here. We are simply trying to add the value to the pointer next right. See, this tree has 3 pointers, left, right, the left child that denotes the left and right child, and one next right pointer. This is some new pointer added to the given tree, and we need to add values to it. Okay, got it. So let's say if you have this example, the next right to 3 is null, but for 1 it's 2, and for 2 it's null. If you have seen here, so for 10 it's null, for 20 it's 30, for 30 it's null, for 40 it's 60, and for 60 it's null. So yeah, I hope you guys understood the question that what you are trying to do here. Now let's move on to this derived approach that how you will solve this question. See, so let me also initially write down here answer. So here for 0 it's null, for 1 it's 3, for 3 it's null, for 4 it's 5, for 5 it's 7, for 7 it's null, for 8 is 9, and for 9 it's null. So as you can see that what we are doing, see, first observation that you have to make here is we are doing level order traversal, correct. At each level we are populating these right pointers to some of the values, correct. We are doing level order traversal. And the second thing that we have to note here is what is right to the node, that is what is right to the node. Okay, so yeah, this is clear that we have to do breadth-first search based on the level order traversal. What we have to do, we have to do BFS, but with some tweak, or we can say with some changes in BFS. So let's say for this same example, as you guys know that in BFS we use queue data structure. So initially what we have this queue will contain only 0, then here queue will contain 1, 3, then here 4, 5, 7, here 8, 9, and here null, nothing. Okay, now so here let's say we make for 0 to null, means for 0 we make to null because there is nothing on the right. For 1, in order to make as 3, then we must know that there is something that is also 3. So here we are also making 4 right to 5 and 5 right to 7. So I hope you guys understood that each time we see this all the elements of all the elements at a current level are present in the queue, correct, and we just need to point it to the right, and we are doing it this way. But in a typical BFS solution is that we don't know what is towards the right, because first we are traversing this node 1, then we would traverse for the node 3. Similarly here, first we would traverse to node 4, then we would know what is there towards the right. So we don't know that in the typical BFS traversal. So instead of this, what you can do, see, can we store something like this? Instead of 1 3, can we store 3 1, can we store 7 5 4? Is that okay? Can we store 9 8 and then null? Why is this beneficial? So in this case, that you know that you have previously traversed for 3, and then for 1's right is what? Previous, correct. For 5's right is what? It's previous. And 4's right is what? It's previous, right? So here what we can do, we can store previously traverse, right? Previously traverse. So, and based on previously traverse, we can know what is coming, we have to come in the right. Okay, so yeah, I hope you guys understood that what is the intuition behind this question, that in the typical BFS we don't know, we can't know what is coming next. We can't know what is next. We don't know this. So to solve this, what we do, we reversed order so that we can know what is previous. And now since we have reversed the order, so what is our previous will become this answer, right? The next, original next. So that's why this approach will work. So every time we traverse, let's say we traverse for this, so we will start traversing from 7. Now 7 will be the previous, then for the next of 5 it would be the 7, right, as you guys can see here. and for next of 4 it would be its previous lead towers. That is fine. So yeah, I hope you guys understood the approach, that how this will work based on the intuition, this intuition. Okay, so and if you have still any doubts in this approach, then do let me know in the comment section. Now let's move on to the coding part, where we will discuss in detail. So this is the simple code here for this. There is nothing much to be, there is nothing much here that you won't be able to understand. So yeah, initially, let's say for this example, let's us try to go through this code. So let's say here initially you have 10, the root is 10. Now in order to push the reverse, what we do, we traverse first the right child and then the left child. So in the queue, initially queue has 10, then we push 30 comma 20, 30 comma 20. So in order to push the reverse, right, we first travel to the right, then to the left child. Okay, so now for the 10 we have null. See, we initialize this next node to null, and we make a current of next, right, there is this pointer to this next node, and we each time we update next node to the current node. So let me show you. So for the 10 it would be null, but let's say for 30 is next, right, would be null. So for the next iteration, what we are doing, we are traversing 30 is next, right, is what, null. Now what is the next node? Now the next node become current, the current node is 30. Okay, so this becomes the next node. Now for when you are traversing for what, now you are traversing for 20. After 30 you will traverse for 20, right? So when you will traverse for 20, its next node would become what, this 30, and this is what we want. We want 20 is next to be 30, and this is what we are doing. So each time we will update the next to this previous, or this is how we are storing the previous node, correct? Okay, and yeah, we are traversing in the reverse order, that is first towards the right and then towards the left. So this is how this approach works. So I hope you guys understood the approach. Means it is simple BFS, but with a simple tweak, right? So yeah, that's all for this video. And now talking about the time and space complexity, the time complexity here would be big O of n, because we are traversing all the n nodes. Space complexity, in the worst case, it would be big O of n, because this queue will take some of the space complexity of storing the nodes. So yeah, that's for the time and space complexity. I hope you guys understood the approach and the coding part here. The code is simple, the approach is also simple. If you have observed it and try to think of how we can get the rightmost node, how we can know that what is in the right, then you would have obviously solved this question, right? So yeah, that's all for this video. Make sure you like this video and subscribe to our channel. Also do keep check the community section, where I'm posting the job opportunities on a daily basis. So make sure you check that out. Thank you.